Hi everybody, so this video we're going to be looking at features of relational databases, and I'm not going to lie to you guys that off the bat this could be quite a bit of a long slog, but at the end of the day there's a number of things that we need to go through and provide some definitions of to help you guys out, hopefully. So previously we've looked at what a relational database was, and ODBS. Of course, if this is the first time that you watch one of these videos, then you might not be quite so familiar with that term, but that is in one of the previous videos that I've done for or on this topic. So if we look at the goals for this session, so we've got a really silly spelling of outcomes. We've got we're going to describe the main features of a relational database. We've got some definitions that we're going to find on data consistency, data redundancy, and data independence, and then we're going to start looking at some of the advantages of relational database over flat file databases, hopefully in a slightly different way that we might have looked at previously. So a relational database, the definition that I come up with is a collective set of multiple data sets organized by tables, records, and columns. So where the big thing here is the relationships between the tables that allow us to be able to use these in a much more powerful and a lot more useful way than a flat file database. So we can do things like storing, well, one of the goals is to ensure that we're doing things like storing data correctly and only storing one instance of that data. And relational databases definitely help us to do that for a variety of different ways. A number of which we will look at within this video. So we'll start off with some basic terms, really. So objects and within that tables and fields. So table is the name of basically the place where all the data is held. I'm sure a lot of you guys are familiar with tables in day-to-day life, and tables are split into rows and columns, but that's actually not the proper way to describe these items. So what we have here, the columns in this make-believe table is something called fields. So these are items of or attributes of the item of data that we want to store data about. So in this instance, you've got first name, last name, address, city, and age. I mean, these are very common things that you would store data about, to be honest with you. Now, each one of these fields would have a specific data type. So a data type is the way that the data is stored within the table, and within this particular table you would basically have four examples of text and one example of number or integer. And why we would do that, and I do have a slide on it later on, is to maximize the storage abilities. So if you got these text items here, they do generally need to be text because you could have numbers and letters, and you can reduce the number of characters that somebody can enter in. For example, first name or last name, probably up to somewhere. I mean, first name probably be about 15 characters, considering what default is 255, and last name is maybe something a little bit longer, and that means that you're able to reduce the overall file size of a database. It's obviously extremely useful. The age here means that you're only going to be storing numbers, so the maximum amount of characters that you're going to store is 3, which again is particularly useful. And also what it will do is prevent an end user from typing in letters into this particular field. So it'll pop up with an error and say that you can't put that data into that particular field. Which again is obviously quite useful, because it will prevent things like on standard keyboards there are a number of keys, particularly below the numbers, and it's quite easy to hit one of them. And what you obviously don't want to do is have those within your database. As I will be repeating many times, that a database or even a system is only as good as the data that goes into it. Because if you put erroneous data into a system, then whatever comes out of a system is going to be wrong. You can't put erroneous data into a system and then correct the erroneous data through your system. It just does not work like that. A couple other bits. So we've got reports and queries. I'll start on queries. So a query is where you request something from within your database. So if you imagine that your database is this big, huge, hulking set of data, and you want to find something within your database, you might well perform a query which will search the database for things. So when I say things, I mean that's obviously quite a vague term. But it really does depend on what you are searching for. So it could be specific word or phrases. It could be numbers. It could be things. A value between two sets of numbers. So it could be higher than 30, lower than 40. It could be finding customers with particular favorites with food sections. If your database is about food, a customer may decide that they particularly enjoy certain types of cuisine and tick that box on the form that they initially fill in. I haven't got forms on here, actually. I don't know why I haven't got forms on here. It's a bit strange. A form is what you use to enter, or potentially use to enter data into a database. So I don't really know why I haven't got it on here, which is a bit odd. Anyway, I've mentioned it, and basically why you'd use a form is because it would have a graphical user interface to make it nicer and more intuitive for an end user, and potentially give them more information. So I guess it will be interesting to see who has genuinely watched this video, because those guys that haven't genuinely watched it won't know about the form that I've just mentioned. So that'd be interesting. Reports. So reports are something that you would use to present the findings of whatever it is that you have found. So it's designed to turn the results into something which is nicely formatted, easy to look at, and you're able to do things like printing it off, and or sending it as an email, or whatever it might be that you want to do with it, and using it for more kind of professional purposes. Because if you just use an ordinary table, it's not really particularly presentable. And it's not like you can have it open in front of, for example, a board of directors. Not least because of issues that might be things like GDPR and data protection that could come into play with that. So reports are extremely useful things within it. There are other things as well that I haven't actually physically written, but I will tell you about, such as macros. So macro is where you would record a set of actions, and then when you can apply it to things like buttons, or you can apply it to things like screensavers. So you can create screensavers for your database. So for example, when you open the database, it pops up with a nice little screensaver. It's not a screensaver, a splash screen. I'll get the word out in the end, and it will display it for you, and it might be a nice little entry, or it could give you information about, so when I say you, I mean the user, information about what they want to be doing with the data, or how to get the best out of something. So there's a number of really good kind of cool things within databases that we can potentially use. The database is primarily written in a language called SQL, which I'm not planning on really going into in this video, but just it is a useful thing to kind of bear in mind. Ultimately, if you want to work with a lot of the bigger databases, you might need to know a little bit of SQL. Okay, so primary and foreign keys. So primary keys are fields within your table which is unique. So by having unique fields, it will ultimately prevent you from having data stored potentially more than once. So while it might be like, how would that work? Basically what would happen is, this is where the things like relationships come in, that you might link to other tables, and you have, for example, a table of customers, and you have a customer that is stored within your table, and what you don't want is, let's say, for that customer to log in and to then have to I guess if they've logged in, then they won't be entering the details again. But let's say if they try to order, I don't know, a pizza twice from a restaurant, and you already have a version of a customer. Let's say they're called Jim Black, and Jim Black tries to order another pizza, and because you're able, or he was, well, I call him a him, might not be a him, who knows, but because they're able to enter the data in more than once, you then may get erroneous things occurring. You might be like, well, why would that happen? Well, it might be something like they've moved house, maybe multiple times. It might be something like if they've changed their name, maybe. It might be if they put in things like credit card details, whether or not they might be right or wrong. So there's all kinds of different things that might change between the two of them. And obviously, if you start having multiple versions of a customer records, then eventually the likelihood of them being wrong becomes greater and greater and greater and greater. And you think about it from the pizza company. Let's say eventually 2 years down the line, Jim Black, there is a Holland on there, Jim Black orders another pizza, and there are 6 versions of Jim Black on the database, let's say that, and then the restaurant has to try and decide which version of Jim Black to send the pizza to, because there are 6 versions of him. There might be 3 addresses, 4 addresses, 5, who knows, and it's going to be a bit of potluck as to where the pizza goes. Not only that, the database is storing this information 6 times more than it needs to, because ultimately it should be stored once and only once, so that if you need to make adjustments to it, you make adjustments to the record and not just adding new records to it, so you end up with multiple versions of them. A foreign key is a field which is a primary key in a different table but links to your table. Okay. So if you think about the theories behind a primary key, basically your foreign key doesn't have to be unique within your table, but it will be unique within somewhere else, within another table. So an example again would be, this customer ID here. So the example is that within this database, the idea is that this student ID is unique. Okay. However, the student might potentially order many pizzas. So if you're talking about an order database for a pizza company, you may have many times where the same student has bought a pizza. However, what you would have that would be potentially unique in that table could be a primary key that would be, for example, order number, because you would only ever have one order. Okay, so that wouldn't repeat. Okay, but the customer can order something many times over potentially. Sometimes you may have a situation whereby you have a primary key, or you look through your database and you can't find a key that would be sufficiently unique all the time. So you might decide to join 2 fields together. So you might decide to join, for example, student ID and first name here. I mean, first name would be a rubbish primary key because it's there's so many so few first names out there. I mean, when I say so few, we're talking about thousands, but it's still not great if you're looking for primary examples. So, but let's say it is, right, and you could potentially join these two together. So the primary key would be L000235 plus Jim. And like I said, that would be if you cannot find in your table something that will be sufficiently unique. But I would query, ironically, that if it gets to that point, then your database probably hasn't been something called normalized properly, and we'll get to normalization relatively quickly. It's probably going to be the hardest thing in this unit, but not impossible. Naming conventions, right? So we're going to have quite a few different topics now. That might be jumping between different ideas, but still things that you guys will need to know and be able to talk about and define. So naming conventions are things that have happened within the computing industry for a long time, well, a long time for IT anyway, and it predominantly comes back to programming, really, where you would have names and you would have software that would not recognize, for example, gaps within words, and that's where companies or people started to put the underscore between the words, so that it would ensure that it works properly, and it's just kind of stuck, really. But although there are still a number of pieces of software which apparently can't deal with it. Now I say apparently because it's not something I work with particularly, but at the same time I am reliably informed that that is still the case. But it also means that you can do things like distinguishing between your naming or your software and something that might come from a customer, because the customer's not going to use naming conventions. So that might be useful. You could use what's called the camel casing, which is where you have the small first letter of the word, and then if you have another word joining into it, that gets a capital letter. Again, that's just convention within IT, really, and being able to tell apart your names and something that could come from elsewhere. It's generally good practice if there is a foreign key to name it the same as the table it comes from. Obviously that makes it easier for you, it makes it easier for another developer if they come along afterwards and see what's happening. Entities. Okay, so entity is an object in the system that we need to store information about. So I have an example here that if we need to make a database about Amazon, and I say they do, I don't know that for sure because I've never worked in Amazon, but I would be shocked if they did not have a great many databases, and they might have all sorts of different entities within their system. Could be employee, it could be stock of some kind, it could be van drivers, it could be any number of different things. And within those entities, don't think that just because something in that example could be an entity of Amazon doesn't mean that they might not have entities of their own. So if you think of them the same way as attributes, pretty much everything is an attribute. If you got employee here, which in this instance will probably become a just person, would have its own entities. So you could have addresses, you could have contact details, you could have qualifications, etc., etc. I'm mindful that I'm already at 20 minutes and I'm not even halfway through the slides, so I'm going to try and not take ridiculous amounts of time. Attributes are part of an entity, right? So from the previous slide, you could have a student as an entity, and the attributes of that student: age, dress, gender, course, ethnicity, and so on and so on. If you have car as an entity, you could have engine size, you could have color, you could have model, and again so on and so on. So attributes, if you think of these as, these will basically what will become your fields in your database, whereas the entity is the overall table, okay, or part of your table, whereas the attribute will be probably the fields, or if you're normalizing, it might become a little table on its own, because you may need to break this down further. For example, if you have something like course here, the likelihood is that if you're in an educational facility, then they're probably got departments followed by individual courses, depending obviously on which department it is. Okay, so if I go back to one of the very, very early slides, which is this one here, so you can see here that there are these blue lines between these relational databases. These are the relations. Okay, and you can see that there are various different notations at the end of these. So there's a 1 here, and there's what looks like a star. It's a bit blurry, and these refer to the type of relationship that is going between these tables. So if I go back to this slide, you can see there are 4 types of relationship that would go between tables. So you can have a one-to-one relationship. So in other words, one record in one table can only have one instance of another record in another table. Okay, so let's say, for example, we've got in their country, it's capital city. So you can only have one instance of a country. There are not many instances of a country ever, and within that country there is only ever one capital city. I cannot think of another capital city in the world. I cannot think of a country in the world that has multiple capital cities. Maybe I get proved wrong by somebody, but you know, that's an example of that. One to many, by far the most common. So you have one record in one table, which could be a primary key, which could be recorded many times in another table. So an example there, you've got student courses. So there will only ever be one student. You know, you guys do not multiply, okay? Which is probably in a number of cases a real relief to me. With the best will in the world, but otherwise I might go grey in some instances. But students do not multiply, or at least at this point they don't. However, one student can go on many different courses, and I speak for myself when I say that I've been on many courses in my life, and indeed I won't stop, because it's one of life's best things to be learning all the time. Many to one. I mean, people say to me, what's the difference between one to many and many to one? It's ultimately the source of where you're getting it from. So if you're having the one to many, you're starting off with something that can be on many different things. Whereas if you've got the many to one, you start off, for example, here you have state. So you can have many states with many cities. Sorry, that's a many to many. I'm going mad. You could have lots of different cities, and they'll all link to one state. Okay, so this kind of going the other way. It's kind of hard to describe in that respect, because you'll just people would just be like, why don't you flip it the other way? And I guess it could happen, but it really does kind of depend on which way you're looking at it and the way the database has been developed. It will function exactly the same as a one to many. Many to many exist, but if your database is normalized properly, they will not exist, and they should not be in databases. Generally, it's very poor practice to include many to many relationship, but it exists, so it's worthwhile knowing about it. So in this example, you could have more than one record linking to a table and another, linking to another table, and there could be more than one instance of that. So in there you've got books and authors. So one book can have many authors. and one author can have many books. So if you're getting a bit confused by what I said, firstly, you only need to look at some of the textbooks for some of the higher level university style courses to see that they have multiple different authors on occasions. The fiction books less so, but the textbooks can have quite a few different options available. Cardinality. Cardinality is referring to the uniqueness of data values. What the hell does that mean? So what we mean is that if you have a column and there is a great deal of data differential, then that means it has a lot of potential unique data. Doesn't necessarily mean it's good. Whereas low cardinality will mean that you get a lot of the same results occurring a lot of the time. Excuse me, I had a bit of a hiccup then. I guess you could be thinking along the lines of it really does depend on the type of database. I don't know why that took such a long time for me to say. The type of database that you are creating. And the type of data that you are storing. And if you have kind of, for example, for low cardinality, you would expect results within a very tight range, whereas your high cardinality mean that you're expecting a great variance in results, and that ultimately will mean that there is a higher chance of the data being wrong, but also you might be able to get what we call richer data, because it could be more unique, and therefore it could be more kind of opinion based, for example. So and I said it depends very much what it is. So I've got an example there. So if you're a bank, you want high data, you want high cardinality on account number, on the basis of there should be only one account number for every account, and therefore you should have millions of different accounts. Whereas gender would be very low, and let's not get into that conversation because I'm sure there are people going, "Oh, Michael, that might not be the case." Optionality basically means, does it have to be there or not? So can the data box be left what we call null? In other words, no data. And sometimes this can be the case. So I've got an example there of a care provider who might provide care for one or more patients, but you may have a patient that is yet to be allocated a care provider. Okay, so you might have records that may not require data on both sides of the relationship on occasions. Consistency, so that basically is referring to does the data meet all the rules, and if your data is set up with suitable verification when you are creating your database, then the answer should be yes. And again, things like normalization would help with this, and I know I'm using that phrase a little bit at the minute. If you think of normalization as reducing redundant data, in other words, or repeating data, so we're getting rid of all the bad stuff, but it's not a topic for this presentation. So the database or the data in the database should meet the rules. So I've got an example there of gender, which, for example, could only allow male, female, or other. Okay, or you may have a rule which says that all customers should be 18 and over, but the max age will be, I don't know, let's say 120. So they would need to ensure that everything is within those bounds. Or if you're selling a computer game, you may say that the minimum value that you'll sell the computer game for is I don't know, 99p, and then the maximum value could be this is a tricky one because I assume that there are some games out there that are extremely valuable. Let's just say $1,000. Okay, and again, you might sit there going, "Oh, I know there are games out there that go for 10k." I'm just trying to give you an example at this point. Some rules can be quite elaborate. So, for example, you think of email addresses, right? So, email addresses are and can be quite varied. So, what you're looking for, or what rule you could set up, would be you start off with the unique ID. So it could be name, and then you have the ampersand and the @ sign. It's not an ampersand. I'm going mad. And then you have the domain at the end. So you could have name@gmail.com. And so what your rule would be okay, has it got the unique name? Has it got the @ sign? And then has it got the domain, the proper domain? So in other words, the for example, gmail.com, hotmail.com, whatever. Does it have all of those components? And like I said, it can become quite complex. Data redundancy. So I've mentioned data redundancy a couple of times already. Data redundancy is where you have fields that are repeated throughout the database, which potentially leads to a risk of errors because one version of the data may be updated, not the other, for example, or you start having multiple different versions of this data, as I mentioned for the pizza example earlier, and also it's taking up huge amounts of space. But don't think that data redundancy is all bad, because as I've made a point on this slide that some data redundancy is done on purpose to back up the data, because if you're backing up data, one of the most common things is to make a copy of that data, so that if the most recent one stops working, that you still have a copy to refer to. You've done very well to keep with me so far, guys. Alright, so data independence. So the ability to make changes to the data without making changes to the programs that access them, which may sound a bit strange, but if you have programs that are using the data that are within the database, let's say a website, for example, and you want to make changes to the data within the database, what you don't want to happen is for your website to go all skew with. That's a real technical term, right? But we really kind of need these things to happen independently, or even the way that the data is something like structured, and not have the systems that are using that data to not run properly. And like I said, that shop idea is probably the most obvious one in my head. Alright, so I think we have actually touched on this on previous occasions, but we will do so again. So relational v flat file database. So a flat file database is one big table, which makes it easier to work with, which is a plus side. It means that it's actually less complex, and that's probably about where the good times end with it. I mean, the only thing that you could potentially think about that would work with it are things like CSV, comma separated values, which are generally quite small text files that might work with it easier. So relational databases reduce errors because of the relationships, because of the stringent processes that are there to stop things like data being entered twice, or data being entered incorrectly. Faster query time because tables tend to be smaller. Scalability, so entering new records is really straightforward. You just kind of hit return if you're in Access. Other databases will vary slightly. Security, so you can apply access rights to parts of your database so that certain people with access rights can access them, and those people who do not, who have no business accessing that data, are not able to do so. We have a couple more slides, guys, and then we will be finished with these items, but they're important because we're looking at data types. So I mentioned earlier that fields are are all going to be a particular data type, and it is important to do this because you've got the ability to change the default setting, and it will mean that you do things like save time. It will do you things like the ability to format it in a certain way. It will make queries run easier. You'll be able to potentially do more things with it. So having the right data type is really important. You can kind of see here this is not my mouse here. This is my mouse moving around. This field size, default setting 255. It's not always what we want. And there are a number of different... I think this is an older version of Excel, actually. And not Excel, Access. And you can see that even here there are a number of different options. So you've got text, this is what it is. Number, date, time. Do you know, I'm not 100% sure what the memo is. I don't think I've ever used the memo. But anyway, you've got enough there to get on with. You've got date, time, pretty obvious what that is. You've got currency, you can turn it into whatever currency you want. Auto number increments the number by 1 for every new record that you have. Yes, no, it's basically a Boolean field. An object linked embedded object. Alright, so if you want something, for example, like an image in there, you will use that. Hyperlink, so it goes to a website. And that's pretty much all we need for that for the minute. Alright, so obviously it's going to be important to think about the data types when you are creating your website. My voice is beginning to get really croaky. Unfortunately, this is the last slide that we have, so that's it's good. We're getting on to 40 minutes. So field properties. So fields can have certain properties. So this is different to the data types. Okay, so the data types is what type of data it is. The properties are think of them almost as attributes of that data type. So you could potentially have something like an input mask. You could potentially change the size of the field. You could potentially set a default value to it. You could potentially put something like a little prompt on there that will allow the user to know what you're looking for when they come to enter it. Okay, so a number of different things that you can do with that, and all of these are really important when it comes to designing your database. Now, like I said, we've come to the end of this video. Well done if you stuck with it all the way through to now. Obviously, there will be more videos to come relating to this topic. I hope that the video has been useful. I would say I hope you've enjoyed it, but you've probably done well not to fall asleep by now, probably in about your 5th cup of coffee. And if so, I salute you. And I will look forward to seeing you in the next video that I do.